So today we'll be discussing about the Spring framework, what is its purpose, how it is useful and all. So Spring concepts, what is inversion of control and dependency injection, Spring AOP, and then Spring ORM, object relational mapping, DAO, Spring Webflow, and then the MVC. So these are the topics that what we are going to discuss in the Spring framework. Now, the reason we are going for the Spring framework is because we have got many problems that are associated with the regular J2EE framework, that is JEE architecture. The complexity arises specifically when it comes to the EJB, JNDI, Java Transaction API, and then JDBC. That is, you have got too many APIs and then you have to write the code all by yourself. And EJB is overused. And even of these days, EJB we are not using it. EJB has been replaced by Hibernate. Now, the problem what we get is if you see the code that we are writing, the JDBC code, where you have to manage the transactions all by yourself. That is, you have to specify where to start the transaction and where to commit the transaction. And if the transaction is rollback or if the transaction fail, then you need to handle the exception all by yourself. You need to roll back the transaction and you need to roll back the state of your objects as well. That is, all stuff is done manually. Complete coding, transaction management is done manually. Rather than that, if you are taking help of the Spring rather than you managing the transaction, Spring Framework will take care of managing the transaction and you need to just concentrate on the business logic. So that is just to give you an overview. Now, if you say con dot set auto commit as false, and once you do the set auto commit as false, and then you write all the code, and then you decide when to commit the transaction. And if any exception occurs, then you need to again handle it. What to do it? How much part should be committed? Con dot. And again, you will write the code for this. So con dot rollback. So what are you doing is you're managing all by yourself. Rather than this, we have the Spring framework that will take care of the transaction management. Now, it is hard to unit test the EGP components, and again you need to deploy them to be able to run and execute independently, whereas Spring components can be tested independently. Now, slow change, deploy test cycle. Now, lightweight containers. The reason we call this as heavyweight container is because, as we have discussed, in order to run EJB you require application server. Application server, it has got two components. One is web container and other one is the EJB containers. Your EJB container will execute, your EJB container will execute your EJB. JDBC anyway, it can be executed. But in order to execute the EJB and any other JEE framework, you require heavyweight container. So heavyweight container will take time to start up and it will take time to load. So rather than that, we can, if you have to execute or if you're using Spring, you need not use any heavyweight container. That is, you don't require any application server. You can execute your you can execute your Spring modules in lightweight container. That is, web container is sufficient to execute the Spring framework. So many projects encounter the same problems. That is service location, as we said, exception handling, parameterizing the application code. So rather than this, so what are we doing is we are removing all this from your Java code. We will remove all this in the Spring. We remove all this from the Java code. We'll place the stuff into Excel. Now, for your requirement, J2E out of the box does not provide a complete programming model. So generally what happens is J2EE, it provides you with some amount of API, but those API will not be sufficient. But those API, as discussed, will not be sufficient to build your application. So what the software development team does it, they will develop their in-house model. That is, they'll develop a model that they will be using to develop the projects within the organization internally. I repeat, that is, when you're using this J2EE framework, it will not have all the modules that are required to develop the project. So if the project requirement does not meet J2EE, it does not meet, let's say it does not meet the project requirement, if it does not have the APIs to support the project development, what they do is they will make use of the existing APIs and they will create a new API that will be used internally within the organization. So that is what happens, results in many in-house frameworks. Okay, fine, well and good, you have developed a framework, but and again it is expensive to maintain and develop because you require a complete dedicated team to support that, and then better to share experience across many projects and choose open source framework. So if you are developing this, then you need to share the experience whatever you have developed across many projects. Rather than that, what you can do is you can pick up any open source framework. Let's say Spring, if you are using, then you need not write the code to develop the framework because it is already being taken care. What you can do is you can just make use of the existing framework and start writing your code. Now, what do the lightweight containers do? So inversion of control and dependency injection, they'll support the aspect-oriented programming and aim to provide consistent framework for the development because it is already tested and deployed. So it is consistent, that is what we say. And the Spring framework and Hive Mind are the most compelling framework. Spring is the most complete, mature, and popular. So as of now, like most of the projects, they are being developed in Spring in the Hibernate. And plus, in addition to that, there are many more technologies that are being used, Apache, Caramel, etc., etc. Based on the project requirement, people will use, or the project development will decide the framework to go for. So in the starting days of the web development programming, yes, you can say that the projects were developed using servlets and JSP alone, the base technologies. But now the projects are being developed using these. Now it is an open source. It is licensed by the Apache, and initially it was written by the Rod Johnson and Jacob Holler, and it was the interface. This framework comprised a team of 21 developers who has written the code for this. And then what are it saying? What are the pros? Is it simplifies J2EE development process and it provides comprehensive solution for developing applications that are built on POJO libraries. And it will provide services for the application from simple web apps to the large financial/enterprise. So it is not like that it is only targeted for the small scale application or the large scale application. So you can start from the basic web project to the large scale financial application. That is the reason it is being used in the projects. So this slide is quite old. Now, This one, J2E, should be easier to use. It is best to program to interface rather than classes. And then Java Beans are of a great way of configuring the applications or design is more important than implementation technology. And checked exceptions, they are overused in Java. A framework should not force you to catch the exceptions that you are unlikely to be able to recover from. And then testing part. So this is what the mission statement is. So that is the Java EE framework. It should be easy to use, and it is better to program to interfaces rather than classes. So they support, you can configure interfaces in Spring. And then Java Beans offer a great way of configuring the applications. And then OO design is more important than any implementation technology, just Java EE. Checked exceptions, they are overused. So when you're using the framework, it is not mandatory to handle it. And then you can unit test the applications. Anyway, we will be discussing all the steps one by one. So it is a lightweight container in both in terms of size as well as overload. Entire framework, all the libraries, they are available in the single jar, that is 1 MB is sufficient, and processing overhead that is required is negligible, and then it is non-intrusive. Objects have no dependencies on Spring specific classes. Now in version of control, it supports loose coupling through use of IOC, and then instead of an object looking dependencies from a container, the container gives the dependencies to the object at instantiation without waiting to be asked, reverse of JNDI. So this is one of the principle of, or this is one of the feature of Spring Container, that is inversion of control and then lightweight. So lightweight, it is very much clear that it is uh, you just require 1 MB for this, and it can be run on your lightweight server, that is the web container, and inversion of control. Now first let us understand what do we mean by this inversion of control. Inversion of control, it is very simple. Now generally how we write the code is, let's say I require object A, then I write this. I have a class B in my application. Within class B, I have class A. Now if I require this class A object, I'll create it this way. That is, you are creating all objects by yourself. Now let's see what happens if I'm using Spring. If I'm using Spring, I'll just do it this way. We have an annotation called auto wired. That's it. Now, if I do it this way, you have a Spring container over here. Spring container will take care of all your beans. Now over here, object will be created, and let's say your object has got two fields, field X and field Y. So these two fields will be destroyed. Let's say I give you two fields, FF, and then let's say I'm typing it as XX. So your object, it has got two fields, FF, and then you have got another field that is XX. Now your Spring container will take care of instantiating this object, and it will provide the reference of this object to your application. So this is reverse process. So it is your Spring framework is at your service. We can say Spring framework is at your service. That is, you just have to write AA. That is, I want an object for class A. Though you're not creating the object at all. You're just auto-wired. You're just specifying it as auto-wired. That is, the responsibility of creating the object is on the Spring container. So whenever your Spring framework will see this annotation in the outer wire, it understands that it has to create an object for you, for your application, and provide it, and provide a reference to your application. So this is the reverse process. Spring Container is creating the object, and then it is providing it to your application. You don't even have to fetch it. You don't even have to look up. You don't even have to fetch for that object. It will provide it the reference to the object that is created by the Spring Container as provided by the Spring itself to your application. Is this clear?
Is it
All right.
work just the inside the package or outside the package also it works?
Can you please repeat?
Does it work inside the package only or if it's outside the package also work?
Anywhere within the application.
Mhm. Okay.
Next, what we have is aspect-oriented programming. Now, the aspect-oriented programming, it is quite simple concept. Now, what we have in the aspect-oriented programming is, just give me a minute. Now, let us understand what we mean by this aspect-oriented programming in simple terms. So, aspect-oriented programming is similar to that of the filters, and if you are familiar with or interceptors. Now, generally what happens is whenever a client is sending the request will hit the servlet directly. Now, this your servlet is having the logic to update. So before you update anything, it is obviously you first has to be authenticated. When you have a servlet to add some information, the condition is before you add some information to the servlet, it should be uh, you should be authenticated. Over here also login. So over here, if you see the login logic is repeated. Login, sorry, login logic is repeated. The primary logic of yours, this red servlet is it has to add, and the primary logic of this is to update the information, and the primary logic of this servlet is to delete the information. Whereas login is the secondary logic. The primary logic, what do we mean by the primary logic is the purpose, the job, or its functionality. So the functionality of this is add, for this servlet it is update, and this servlet is responsible for deleting it. But if you observe what we are having is, but before you add, it is mandatory that the user should be authenticated. Before you update, it is mandate the user should be again authenticated, and before you delete, again it is mandate the user should be authenticated. So this login will form the secondary logic of your application. The login will form the secondary logic of your application, and it is repeated. And the logic is repeated. So what do we expect is, so this login logic is repeated. So if there is a change in the login logic, if there is a change in the login logic, then it has to be changed at all the places. You need to change. So maintenance is difficult. Maintenance is difficult. Point number one, there is the repetition of the code. Point number two, it is very difficult to maintain. So rather than that, what do we do is, it is better you remove this logic. So the main purpose is to separate primary logic from the secondary logic. That is, your servlet should only take care of primary logic of the application, whereas secondary logic should be removed. So what do we do is, this logic is repeated. So cross-cutting concerns. So this is called as cross-cutting concerns because it is spread across various components. So whenever we are writing the aspect-oriented programming, we pick up the cross-cutting concerns. So you remove all the cross-cutting concerns and you place them in a separate class. So over here, you're placing it in a separate class. So you need to only maintain one class for this logging. And if you observe over here now, second, you it has to be authorized. Now you need to authorize to update as well as to delete. You cannot delete as you like. Uh, you should have the authorization. You should have the power to update the information as well as delete the information. So again over here the authorization is the secondary logic of the application that is again repeated. What you do is you remove this and you place it in a separate class. So over here, what are we doing is whatever cross-cutting concerns is the stuff that is spread across the application. You remove them and you place them in a separate class so that you don't have to repeat it every here and there, and this behaves or this works as a pluggable feature. The reason we call this as a pluggable feature or pluggable technology is if required, you can apply. If not required, you need not use that feature in your application because this feature, the authorization feature, is required in update and delete. So you are plugging it to this one and you don't require in add. You don't require this feature in add. So you're not using it. So that is what we say it is a pluggable technology. You require, you plug it and you can use it. If you don't require, you just remove it. So your base code is not going to be affected. The base code is not affected at all. Clear on this?
Yes.
So this is what is cross-cutting concerns. The same is implemented through aspect-oriented programming. So in each technology, it has been given a different name. In Hibernate, you call it as interceptors. In Spring, you call it as AOP. And again in EJB, it is called as interceptors. And in your servlets in GSP, it is called as filters. So hold on for a second. So that is what is aspect-oriented programming. Wherever the logic is repeat, you separate the primary logic and the secondary logic of the application. The secondary logic of your application is called as aspects. And this now, the next big thing what we have is the container that manages the life cycle of your application object. Now manages the life cycle a bit what we have discussed over here is if you see this is the Spring container, you're not creating the object all by yourself. This object is being created by the Spring container. So Spring Container will take care of creating the object for your application when required and providing the reference to your application. So this object, if you see, it is created by the Spring Container in a managed environment. When you say managed environment, that is the life cycle of the object is controlled by the container, not by the application. And then after the object is created, it provides the reference of the object to the container. It provides the reference of the object to the application wherever requested. When it is a single instance or a new instance, each time you have to specify whether it is a single instance for your application or the new instance. Each time it should create a new bean whenever it is requested for. So we can configure this information based on the configuration it will create. And then framework you have. Spring make it possible to configure and compose complex application from simpler components. And application objects are composed declaratively, typically in an XML file, provides infrastructure functionality, transaction management, persistence, framework integration, etc. etc. So if you have to provide the instructions to the Spring framework, let's say you have to provide the instruction to the Spring framework to create this object. So rather than writing the code in the Java, you will be taking help of the configuration files that will contain all information in XML. So let's say if I have to create this is how I'll specify bean ID is equal to A. That is the name of the bean. We are specifying it as A. And the class as fully qualified name com dot example. This is the package name dot A. That is it should create an object for class A, and its name what you're giving is A. And if you observe this class, it has got two properties. Property name is equal to, let's say I'm keeping it as f name, and then value you need to specify. So what the Spring container will do is it will read this information. Property name is equal to f name, and the value for that field will be initialized to John. So value for the field is initialized to John. The next what it does is it again reads property name is equal to L name, and value for the V, let's say you have this, and then you have the closing tag. So rather than you calling you writing the Java code, you write the code in terms of XML, and this code will be read by the Spring container. When this code is read by the Spring container, it will create the object, and then it will initialize the field by reading its value from the XML. So that is what we are discussing. So Spring makes it possible to configure and compose application from simpler components, and application objects are composed declaratively, typically in an XML file. Clear with this?
Yes.
Yes.
And then provides infrastructure functionality, transaction management, persistence framework, integration, etc., etc. So now you don't have to write the code for transaction. Let's say you have to specify when to start the transaction and when to begin the transaction. When you go with the code programming, you write the code all by yourself. So when you're going with basic programming, you decide when to start the transaction and when to end the transaction. Whereas in the Spring framework, you have the transaction management framework. You can decide, okay, which bean is a part of the transaction, which bean is not a part of the transaction. So we have got the transaction management API that will take care of transactions. Now over here, if you see, this will make it pretty clear. So these are the various modules, JDBC and the transaction management. So if in case if my application requires transaction management, then I can make use of this module. And then you have the object relational module. If you let me slide show. So you've got ORM, object relational mapping. So it supports Hibernate, it supports your JPA, Toplink, JDO, OJP, and then IBATIS. These are the various ORM framework that is supported by the Spring. And then your JEE, it supports JMX, JMS technology, JMS, JCA, remoting, EJB, and all these technologies are supported. Then under web, you have got Spring Web MVC, framework integration, struts, webwork, tapestry, JSF, rich view, so all these are supported. And at the base, you have got your Spring Core and the Spring IOC container. On top of these, they are the various modules that are supported. It is not mandatory for you to use all the modules. It is based on your application needs. Whichever you're using, you can make use of that. Otherwise, you can just omit it.
It doesn't support servlet.
Your servlet will come under web.
Okay.
Your servlet will come under this one, this part.
Mhm.
If you're using JDBC, then it'll come over here. ORM will come over here. Your AOP will come over here. Now what you need is you just need to download the code. If in case if you're using aspect-oriented programming, then you have to make use of these libraries. Let's say you're just using core. You're not doing you're not providing any hardcore program. You're you're just developing the application for a desktop application. Let's say you just require core, and within that, okay, you're using AOP features, so you make use of it. All these libraries you need not import it. You don't require all these libraries because you're not using it. As of now, first initially we'll use AOP. Then if I want to make use of AOP feature, I'll include just libraries. So whichever feature you require, you just need to import those libraries or include them in your application. I'm not using any JDBC stuff. I don't want to use ORM. I am not developing a web application or JEE services, so I don't require all this. So whichever you require, those modules, you need to include them into your application.
Is there any difference between Spring Framework and Spring MVC?
Can you repeat your question?
Is there any difference between Spring Framework and Spring MVC?
Okay. Your Spring framework is basically, when you say Spring framework, it basically includes all the stuff, your core Spring and all, okay, to include this. If you see over here, what is Spring framework? It supports all this. Spring framework, aspect-oriented programming, it provides the support for the container. And then, okay, this framework, it makes it possible for these features, and then it is lightweight, it is inversion of control. This is what it is saying. Now, when you say specifically Spring MVC, model, view, and then the container, that is your Spring framework is built on this model, view, and then the container. So your Spring, when you say Spring framework, it is describing the features of the framework overall. And then okay, within that we have got one more module that is called as Spring MVC. Within the Spring framework, we have got another module called Spring MVC. So this Spring MVC, this module, it is built on model, view, and then the controller technology. So when you say when you speak about Spring framework, you're speaking in general, and when you say Spring MVC, you can discuss about the Spring MVC module in specific.
And the Spring MVC only comes in the Spring Web module.
Spring
Spring MVC only comes in the Spring Web module.
Spring Web module is different. Spring Web MVC is different. Struts integration of Springs with struts, that is different. Web work. So this will come under this module. Now over here you see you will get all the libraries. Over here, right click and oh sorry, over here, and if you say add library, where is that? Spring Web MVC, Spring Framework. So if you say Spring Framework only, so it is going to add the core libraries to your application. So when you give this, okay, you get all this stuff. Let's say you want some Spring specific. So over here it has added this. So these are the few additional stuff. Okay, you will get it with the Spring Web MVC. So this is for Portlet, it is something different. Now this is MVC, Web MVC framework. Now if you see over here, AOP is not included over here. See over here, if you see, you have got AOP. Oh, fine, AOP is also there. So that means it is including all the files. But if in case if you are using or you are developing with the help of what do you say, Eclipse, then you need to include certain AOP libraries. Is this clear?
Mm-hmm. And what is the difference between the Struts framework and the Spring framework?
Struts, again, it is a different framework, and Spring, both these are two different frameworks. Now, your Struts framework, as we have discussed, again, it is based on the MVC pattern. But when it comes to the Struts framework, the development and all, that is quite more easy when it compared to the Spring. That is, your Struts framework, it does not provide any support for the transaction and all. That is, you need to write all by yourself. Complete coding, you need to do it by yourself. But whereas when it comes to the Spring framework, it is providing a lot more support. AOP, it is providing JDBC integration. You can easily integrate with Hibernate anyway. You can start also, you can do that. And you've got a lot more, what do you say, benefits when it compared to developing the application configuration. You can do it. The configuration, what you do in the Spring Core container, you cannot do that in the Struts container. The Spring container, it is pluggable, it is open for what do you say, modification, and closed for, sorry, open for modification. That is, you can modify it easily, closed for modification, and open for integration. So that feature you don't get in Struts. So there are many features. So
Okay.
these stuff, okay, you don't get it in the Struts framework, which you get it in Spring framework. So, and then you have got Spring MVC framework and take advantage of the Spring M services. Now, over here you have support for several web-oriented transparently handling multi-part requests, programmatic binding of the request parameter to your business object, contains integration supports with the Jakarta structs. So it can be integrated. So this is what is your Spring Web module. So see, this is how it is built up. So first you have got the server container, that is Tomcat or Jetty. You don't require any application server to run this. And the base you have Spring Core and the Spring DAO that will support the Hibernate mapping and the custom Hibernate DAO. And then on top of that, okay, you have got Spring AOP, aspect oriented programming and object relational mapping. And then you have your custom business logic with the help of the Spring context. And then you have got declarative transaction management for POJOs and the Spring Web and web application context, providing example messaging, all these services on top of Spring, that is Spring Web MVC. And then on top of that, what are the features that are provided by the Spring MVC is form controller handling, multi-part resolver to handle multiple client requests, dynamic binding of the data to the domain model, and it integrates well with the JSP velocity, XSLT, PDF, etc., etc. It integrates. And if you are developing any other API, it can also be integrated. So is this clear?
Yes.
So it is layered architecture. Each layer provides some specific services. So initially we will be working on Spring Core. Now then Bean Factory and then the application context. So these are the two objects that are provided by the Spring framework to get reference to your beans. So it has got the extent. So first it is a Bean Factory interface. It operates Bean lifecycle, instantiation, configuration, and the management. So the purpose of the Bean Factory, we said like your Spring container is responsible for creating the bean. Your Spring container is responsible, we said, is responsible for creating the bean. So when we say when it is responsible for creating the bean, there should be some code or there should be some application logic that is inside the container that is responsible for reading the configuration files and reading the data out, or sorry, and creating the object out of it. I repeat, when we say that the Spring container is going to create the objects for you, then within the Spring container, there should be some application logic written to read the configuration files and create the objects out of it. So the logic for creating the beans is with the bean factory method or with the bean factory interface of the Spring container. The job of the bean factory is to read the configuration file from your application and then create the objects out of it. So the job of the bean factory is to, that is, it provides the bean container, that is a repository for your bean, and it operates the bean lifecycle, that is the instantiation, and then you have the configuration and then management. So all these three lifecycle methods are managed by the bean factory. So it is an implementation, as you said, it is an implementation for the factory design pattern. And then it is an instantiation of the beans, configuration, management of one or more beans, and creative association between the collaborating objects as they are instantiated, thus give fully configured, ready to use objects. So what do we mean by the last statement is, now class B is associated with class A. That is, within class B you are having class A object. Now let's say I have got one more class called class C. Within this class C object, I require an object of class B. I require an object of class B. And within this class A, you're having, let's say, you're having a property called private string hello. Now, when you require class B object, now let us understand how does it create. So we are saying that you require a class B object. So Spring, what it does is now it creates a class B object. Now this class B object, it has got two things within it. One is the field itself. One is the field itself. And the next what you have is the reference to this field. One is the field itself. The next what you're having is reference to the field. So the container, it should create two objects because these two objects, they are associated with each other. This is B and B is associated with A, and in class C you are requesting for this object. And these objects, these two objects, they are associated. These two objects, they are associated with each other. So if in case if there is any association among the objects, then that is done by your Spring container. Your Spring container will take care if there is any association between the objects. So you don't have to write the code to associate for the association. Your Spring container will take care of all the association mappings between the object. So is this clear? Creating associations between the collaborating objects as they are instantiated, thus giving fully configured, ready to use objects. Any questions on this?
Atika, can you show the diagram that you were creating with the can yeah, even if I don't say auto wired for B, still the framework will take care of doing auto create.
Yes.
Like here I understand A for creating object A we have put auto wired and container will take care of creating this instantiating it. But here we did not specify anything, right? Like annotation.
Okay, this one.
Yeah, yes.
You can provide the annotation.
Do we have to or like how it takes care?
Automatically it will be done. No issues. If you want to provide, you can. Otherwise, it will take care. So there are two ways it can be done actually, because we were discussing on this. So either it can be done with the help of XML, or else again you can provide the auto-wired annotation. So over here,
Yes.
if you're creating a class with the same name B,
Mhm.
let's say, so automatically your class will get this reference.
Okay. Okay, either this or that. Okay, that point I did not. I was under the assumption I had to do the annotation and XML. It's or. It's
Mhm.
either this or that.
Yeah, if
Okay.
you are providing over here, then it will easily map this to this. Or else if
Okay.
you are providing auto-wired, then again
Mm.
it can be done either XML or it can be done using annotation. Choice is ours.
Okay.
XML, you need to write a lot of code, but again there are certain pros and cons based on that, based on the business requirement. You need to decide.
Okay. Mm. Got it.
Anyway, we will be discussing both the ways, how to do it using XML, when to use, like, rather than specifying auto wired, what is the use of the auto wired and how to configure that property. We will be discussing with the help of XML as well as with the help of annotation, so that it becomes pretty clear when we do an example with that.
Okay.
So if you just observe over here, your application context is the main interface. You can say it is the root. It will have complete access to your application. Your application context, it is the root. From there, okay, you have got rest of the stuff. That is, once you get access to the application context, then you have, like, if you're using web, then you need to go with the web application event, configurable resource loader if you have to resource any database resource, or if you have to load any files if you have to load, then you can make use of this. If you need to send some messages, then you can take care of this. And you've got this bean factory. And if you observe over here, this is your bean factory, and then listable bean factory is another stuff, and your application context is extending your bean factory. So you can say this is extending this. Your application context is extending the bean factory, because this is, if you see, this is how the chain is going. This is extending this, and from here you have this bean factory. So this is how it is being extended. Clear with this?
Yes.
So your application context will have all the features of the Bean Factory. Bean Factory was used in the previous version of the Spring, but now it is deprecated. We will use the enhanced version of that, or the extended version of the Bean Factory, that is application context. So if you have access to the application context, you will get all the features. So, so there are various interfaces that are provided. So if you're working or if you're performing something on web application, then you use this web application context. And then application event publishing, you will use this. If you are like input stream resource, if you're working with some files or the database resources, then you will make use of the resource loader. So based on your requirement, you will make use of any of the interface. And if you observe it as all, these are all interfaces. These are all interfaces. So your Spring framework, it is based on the interface-based programming. That is what they have discussed. That is one of the feature of the Spring framework is it is interface-based. It is now over here if you see, you're creating an interface called greeting service. And this class greeting service implementation, it implements the greeting service. And within this, you are having, let me just, over here, you are having private string greeting. This is your variable. And then you have the constructor and the constructor with the arguments. You have one is the constructor, the second one is constructor without the arguments, and then you are providing the public setter and then the getter methods. So this is your constructor, and these are your public setter and the getter methods. So once you have done that, now you have to instantiate this object. You have to instantiate this. Where is this? This one should be instantiated. You need to create an object for this. So if you have to create an object for this, so this is how you're creating. So you're creating an object for greeting service implementation. So if we write the corresponding Java code for this, so if I write the corresponding Java code, let me take help of the notepad. Now, um, now if we are writing the corresponding Java code, this is how we write it. Greeting service implementation greeting service is equal to new greeting service implementation. So you are not hard coding any stuff. You are just providing the information in the XML file. So your bean container will read this information from the XML file and then create the objects out of it. And then okay, you have got property. So if you have to set the property, what we do is greeting service dot set greeting, and the value what you're passing is hello world. So if you have to create the objects, you do it this way. But if you are creating it, this is how you're creating it. So the root element is your beans. All the beans will be configured within this. And then if you're instantiating a specific bean, that is your bean, that is within the bean container. If you want to create this bean, this is how you create it. Bean ID is equal to greeting service. That is the name of your bean. And it should create an object for com.example.hello.greeting service, and then property name is equal to greeting value is equal to hello world. That is, it should create an object for this. Clear with this?
Yes. Mhm.
If you have more properties, then this property tag has to be repeated. Hassan, is it clear?
Yes.
Now, uh, if you see over here, you can either use the application context or you can use the bean factory. But now we will be using application context. So file input stream hello.xml. That is, we said your bean factory is responsible for creating all your beans. As discussed, your bean factory is responsible for creating all the beans. So bean factory, new XML bean factory, new file input stream, hello.xml. So that is your bean factory should read all the information, or it should read the information from your XML file. This is your XML file. This file name is hello.xml. So the bean, so you have this. Let me just, I hope it is copied. One minute. So let's say, okay, this is your hello.xml file. Let me decrease the size because we have already discussed what the stuff is there inside. Now this is your sorry, this is your hello.xml file. The file whatever you have written which contains all the information related to the bean. So this hello.xml file should be passed as an argument. So your bean container will read all the XML file and then it will create the object. Clear with this?
Yeah.
Let me just increase the size. I'll remove all this DTT definition so I get some space. Just one second. Let me increase the size. Okay. So it reads this file. Now again if you observe your once the bean factory reads this file, okay, once this is provided as an input to this file, your bean factory is going to create a greeting service object. And once this greeting service object is created, its instance variable or its property value greeting is initialized to hello world. So this all happens in your container. This all happens in your container. Now, if you observe over here, the container has already, sorry, the bean container is already created and you are getting the reference to the bean factory.getBean of greeting service. So within your application, that is with the help of this bean factory object, it will refer to this. So with the help of this, you are getting reference to this bean. Clear with this?
Atika, one question. So it's not the object is not getting created when we are trying to get a bean when we are using when we are using the bean factory itself when we are creating the object for the bean factory using that file that time itself. Suppose say in that hello.xml. Suppose I have defined multiple beans. So all those objects will be created that time itself
Yes. If in
while
case,
loading it.
yes, all the objects will be created. Or else you can specify multiple XML files. Let's say for module 1, I require some ABC objects. So I will write it in m1.xml. Module 2,
Okay.
I require XYZ. So I will create one more XML file called m2.xml. So based on your requirement, you can load it. You can create
Okay.
separate XML file based on the requirement. I require XYZ, I'll go with M2. I require ABC, I'll go with M1.
Mm.
So
Okay.
we are free to use. And then okay, you're calling greeting service dot say greeting. Clear on this?
Atika, one more question, just making sure. Why, when we are trying to get a bean of a particular, we are giving the particular bean ID there. So that time, so whatever it is returning, that greeting service, I mean the left hand side, is that the interface that we have defined in the beginning? That you know what I mean, like that on the left hand side, the class name that we have specified greeting service, not the
Uh,
object, the class. That is the interface, right? The first interface that we have defined. So it is returning that it is returning an object of type greeting service, right?
yes, greeting
Do you
service.
understand? Sorry, I don't hear you.
It is returning you the object of this greeting service implementation, this one. Because interface, it suppose, is a relationship. That is the reason you are able to typecast this to interface.
Okay, okay, got it. Okay.
And then you call it say greeting. Now let us see how to build an application. Java application, click finish. Okay, first what you need to do is you need to configure it. Under libraries, we have got only JDK, add Spring Framework. Right click, add library. If you have, well and good. If you are using Eclipse, then you need to download Maven. If you see over here, NetBeans is just providing all the framework together, but over here you require Spring Core framework. So this is the Spring Core framework. Um, Current framework is 4.2.5. So this is the release. Okay, if you see again, you have got the file that is of 1 MB. So you require this file. So if you are using Eclipse, you need to just download this. So after you have done this, you can add them to the libraries. See, over here you have got code. So that is what we say. Like based on a requirement, you can download. Let me add all this stuff. Mm, Spring Framework. So generally, okay, if you are doing MVC, okay, all this stuff, okay, you require all this. So it has got all the jars that are included, or else if you don't require, you can download it and use it. Don't keep two files because it will conflict. I'm removing this. Now, first you need to create an interface. Of, let's say you are creating greeting, click finish. Public interface greeting, and then you are writing a method public void. greet me. And then you are writing an interface for the same. Over here, there is a standard practice. Whenever you are implementing an interface, you will suffix the extension IMTL. That is not mandatory, but it is the standard practice to show that, to specify that we are implementing this so and so interface. So this class implements the interface name followed by IMTL. Implement all the abstract methods. Okay, 1 minute. So over here, if you see, so in the greeting service implementation class, you're writing private string your greeting message. And whenever you're writing this, it should have a constructor, default no argument constructor or constructor with the arguments. And then your class should have setter and then the getter methods. All the properties of the class should have setter and the getter methods. And you will just print over here system.out.println. Message. Finished. That's it. Now, next important parts, what we have is you need to create a Spring configuration file. Right click, new other, Spring XML configuration file. Click next. You can give any user defined name. So what I require from this is, okay, I don't require any of these. Okay, I don't require, I'm just selecting it just to explain. Now over here, you have to specify what is the DTD you are using. So I just included AOP, but we actually don't require. We are just using Spring Beans. So when you're creating Spring configuration file, this should be included. And if I don't require this straight away, I can delete this because we are not using AOP feature. We are not using any AOP feature. Let me delete this stuff. Okay, it's fine. And remove this also. You don't require this. So this is how your basic bean configuration file look like. Let me check the validity of the document because I made some changes. I go to hello.xml, right click and then validate it. Okay, fine. Done. Perfect. Now over here you will be creating the instance of the bean class. So bean ID is greeting service and the fully qualified name of the class. What is a package? From it is Spring Demo. Spring Demo dot greeting implementation. Now once you are done with this, then you need to instantiate the property. Property name is greeting message and value what we are providing is greetings for the day. Have a good day, etc. etc. Whatever. Done, finish. Now, now you go back to your main class. Application context. Context is equal to new class path XML context. There are various contexts that are supported. You can use any, and then you need to specify the location of the file. If in case if it is able to find and then load the file, it will return as not null. So first we will check whether context is not equal to null. If it is not equal to null, then it means the file has been loaded successfully and the objects have been created. System.out.println. Before you run, just check it. Loaded. Config file is loaded successfully. Right click and then run file. Where is that? Source slash. What is the name I'm giving? Let me. I think we need to use file system source slash spring config file is loaded. So once the file is loaded, I can start detailing it. So I'll create greeting service. So get the help of this context dot, and then you have got get bean. You can specify the ID whatever we have written, and greeting implementation dot class. If you use this way, then you need not typecast.
Atika, here why are we specifying the class? When we specify that ID itself, isn't it sufficient for the bean factory to know like which one to be instantiated?
Now, in that case, if you're removing this, then you need to typecast this object.
Okay.
Otherwise, I
Okay.
cannot define.
Okay.
What did we write?
Do we have to define a single argument constructor in that implementation?
If you don't write it by default constructor, sorry, the system will do it for you. Java compiler will provide the default constructor if no constructor is provided. Because when it is creating the
No. Here, yeah, no. The reason why I'm asking is here we are providing the value for the greetings message, right? So in that case, do we have to define it?
this one,
No. That one it's a no argument constructor. It's singular one argument the one argument constructor. Do we have to define it?
okay, fine. So there are two ways of initializing. One is setter injection and the second one is constructor injection. Now what are we doing? If you're using properties, then you're using this as your setter injection. That is, values will be inserted into the beans with the help of setter and getter methods. So you require setter method for this. If you're
Yeah.
populating the values into the beans with the help of constructor, then you need to define the constructor. There are two
Okay.
ways of injecting the properties into the bean. One is setter injection, the
Okay.
second one is constructor injection. So the one what we are
Okay.
using is setter injection. That is, the values will be instantiated with the help of the setter and the getter methods. In that case, you just require
Okay.
a default no argument constructor and you require setter and the getter methods. If you are
Okay.
instantiating the bean with the help of the constructor, then you need to write augmented constructor. Now what are we doing is
Oh,
setter injection. This is called as setter injection. The
okay.
system.out.println, uh, let us call the message. Greeting service dot greet me. Greeting service dot greet me. Right click and then say run file. Greet me greetings for the day. Clear with this? Over here, greetings for the
Can
day.
we one time can we see the implementation class? Sorry. Greetings implementation.
You have just
Okay.
written one
Yeah.
property,
Got it.
one setter and getter. Likewise, you can like based on the business requirement, you can write n number of properties and you can instantiate them with the help of
Okay.
containers, string template. So what we need to learn is all the configuration information you're providing over here. This file is provided as an input to the bean container from where it is reading the values and creating the objects and providing it to our application. So you don't want, let's say, uh, you don't want this. You want again instead of this, you want to change it to some other stuff, or else where is this Spring Demo greeting implementation? Private string from. Let's say you're writing this alt insert and then you rewrite one more stuff that is getter and the setter and greeting me, greet message, and then plus from. If and then okay, you need to write one more property over here. That's it. So if you're initializing this property, it is going to call. So what is this? The another from, and then click over here. I'm done. Clear with this?
Yes. Can you show if you have time? Can you show us how it's done through a constructor?
That we will discuss tomorrow.
Okay. No problem.
Tomorrow we'll work on the constructor and then it will move to the next part.
Okay.
Okay, we'll wind up for today and we'll meet tomorrow.
Okay, Atika, thank you.
Okay,
Bye.
bye. Just practice this.
Mhm.
Hassan, do you
All
have
right,
any
thank you.
questions?
No.
Okay, fine.
Bye.
Okay, bye bye.
Bye. তুমি জানো কত ধরনের যে সাউন্ড বার করলাম? মনে করবে যে ওই মেয়েটার বাসায় আছে।